Today we're going to put together everything we've learned in Chapter 9 in order to solve right triangles. When we say solve right triangles, that means solve for all angles and all sides. So there are multiple ways to solve for angles and sides. We've been learning them all of Chapter 9. The first way that we learned to solve for sides was the Pythagorean theorem, which is a squared plus b squared. So the Pythagorean theorem is a squared plus b squared equals c squared. We can use this to find a missing side if we already know two of our sides. Now our other option to find a missing side is our trig. So our shortcut, SOHCAHTOA. And we can use this to find a missing side as long as we have one angle measure and one side. Now in order to solve for angles, we have two options. The first is the triangle sum theorem, and that's that all angles add up to 180 degrees. So if we know two of our angles, we can use this information to solve for our third one. And our last option to solve for angles is inverse trig. So inverse sine, inverse cosine, inverse tangent. And we did this recently, and this just requires us to know two of our sides. Once we know two of our sides, we can use inverse trig to find our missing angle. So, looking at this first example, we have one angle and one side. So we need to solve, I'm going to label this triangle A, B, C. So first let's solve for angle C. Since we know two of our angles, our 90 degree and our 360 degree, we can just do 180 minus the sum of 36 and 90 in order to get our angle C. So we know our angle C is 180 minus 126, so 54 degrees. Now in order to find our missing side lengths, since we have one angle and one side, we're going to have to use our trig functions. So we can label our triangle. Across from our 36 is our opposite. And if we're looking for AB, we'll call that x. That's our adjacent. The trig function that uses opposite and adjacent is tangent. So we know to solve for side AB, we can do the tangent of our angle, 36 degrees, equals our opposite over our adjacent. We're going to multiply both sides by x, and then we're going to divide by tangent of 36. So we have x equals 7 divided by tangent of 36. 7 divided by the tangent of 36 gives us x equals 9.6. Now we also need to find AC. We're going to call that y. And that's our hypotenuse. So we have our opposite, and we're looking for our hypotenuse. So in order to find AC, we're going to have to use our sine. So we're going to take the sine of 36 degrees equals our opposite 7 over our hypotenuse y. Multiply both sides by y, divide by sine of 36. So we have y equals 7 divided by the sine of 36. So we know y equals 11.9. These are obviously rounded to the nearest tenth. So once again, very similar example. I'm going to label my triangle. All right, so easiest, let's find angle A first. We can just do 180 minus the sum of 90 plus 32. We get that angle A equals 58 degrees. We're going to call side AB x and side BC y. So in order to solve for x, once again we have an angle and a side, so we're going to have to use trig. X is our opposite side, y is our adjacent, and 18 is our hypotenuse. So we have our hypotenuse and we're looking for our opposite, so we're going to use sine. So we can take the sine of 32 equals our opposite x over our hypotenuse 18. We can multiply both sides by 18. 18 times the sine of 32 is 9.5. Now in order to find y, we're looking for our adjacent, and we have our hypotenuse, so we're going to use cosine. So the cosine of 32 equals our adjacent y over our hypotenuse 18. We can multiply both sides by 18. 18 times the cosine of 32 is simply 15.3. Now in this problem, we're only given two sides. So in order to find our third side, we're going to have to use our Pythagorean theorem. A squared plus b squared equals c squared. C is always our hypotenuse, so it's always this length. So we're going to be looking for c. So we can do 16 squared plus 30 squared equals c squared. We get 1,156 equals c squared. We can take the square root of both sides. The square root of 1,156 is 34. If we're not a perfect square, we'd have to simplify our radical. But so we know c equals 34. Now we can look for our angles. I'm going to label my triangle again. All right, let's look for angle C. So if we're looking for angle C, we know that 16 is our opposite and 30 is our adjacent. So we're going to have to use inverse trig since all we have is side lengths. So which inverse trig function uses opposite and adjacent? That's tangent. So we're going to take the inverse tangent of our opposite over our adjacent. The inverse tangent of 16 over 30 is 28.1 degrees. Now in order to find, so that was angle C. In order to find angle A, all we have to do is 180 minus the sum of our angles, so 90 plus 28.1. And we get that angle A is 61.9 degrees. And now we've solved our right triangle. This last one's very similar. Once again, we're going to use the Pythagorean theorem since we're given two sides. Our hypotenuse is c, so we can do 8 squared plus 11 squared equals c squared. We have 64 plus 121, which is 185, equals c squared. We will take the square root of both sides. The square root of 185 does not simplify, so we can leave it just like that. Now let's label our triangle. All right, let's look for angle A. If we're looking for angle A, 11 is our opposite side, and 8 is our adjacent. So since we're looking for an angle and we only have sides, we're going to have to use inverse trig. So we're going to take the inverse tangent, because we have opposite and adjacent, of our opposite 11 over our adjacent 8. The inverse tangent of 11 divided by 8 is 54 degrees. So that was angle A. Now in order to find angle C, we can simply do 180 minus the sum of our other angles. And we get that angle C equals 36 degrees.